Use Case 2, Wildfire Detection, presented by Nature 4.0. Nature 4.0 is an Italian company built on the idea of giving nature a voice through technology. We have done this by designing and building IoT devices for digital management of the environment, from forestry to crops to wildlife to marine ecosystem and even cultural heritage. Our flagship product is the Tree Talker. This device allows us to collect data about tree health, from its water usage to its radial growth and even its long-term stability. It also allows us to collect environmental data, like solar radiation and microclimate data, like air temperature and relative humidity. However, tree health is only one part of the forestry management equation. The other, wildfires. Every year, they devastate our planet. Millions of hectares of forests are destroyed, and lives, communities, and properties are threatened. They also pump massive amounts of pollution into our air. The key to fighting them? Early detection, making sure a flame is detected before it spreads into a massive wildfire. So, our solution is the Fire Talker, a device to detect wildfires before they spread. Here we can see an exploded view of the device. On the top, we have the IR and visual camera. Just below that, we'll see the gas sensors board. From VOCs to PM to CO2, this sensor board can detect it. Below that, we have the connection module that allows us to send all this data back to our server. And finally, the main board to collect the data and offload the image recognition software to the COGNIT framework. This is the device in its final configuration, as it will be mounted on the trees. Here we can see tests that we've done with the device. On the left, we have the visual camera, and on the right, we see the infrared camera. From a few meters away, both cameras can easily detect a flame. Moving further away, it is still immediately clear that there is a hotspot at the center of the infrared camera, and after close inspection, a flame can clearly be seen in the visual camera image. This highlights the importance of having both cameras, one for a quick on-device check, the infrared camera, and one for further processing by both the machine learning model and a human operator. This RGB, or visual, image is essential for reducing false alarms and therefore reducing costs, as sending the Civil Protection Agency to a fire that is not ongoing can have a significant cost. We can also see a potential deployment of our system. Some trees will be outfitted with these devices, enough to have almost total coverage of the forest. A private LTE network can be set up if there is no LTE coverage. This will communicate directly with the civil protection server that is typically located nearby forest. Additionally, emergency edge nodes can be deployed near forests and outfitted with satellite internet communication to ensure redundancy and make sure that in the event of a fire, data can be transmitted to the Civil Protection Agency. During normal operation, the Fire Talker will collect data from its sensors and send this data every hour to our server. In the event of these sensors detecting the possibility of a fire, an image will be taken with the RGB camera and uploaded to the COGNIT framework. The framework will then run a machine learning model to see if a fire is detected. If that's the case, a few things happen in quick succession. The image is sent to the Civil Protection Agency so that a person can verify a fire is actually present. Then, the device will wake up nearby devices and those will also take a picture of their surrounding and offload those image processing to the COGNIT framework. This will cause a massive data surge while still requiring very low latency and high reliability. These devices will keep contacting and keep taking pictures to upload to the COGNIT framework every minute to make sure the fire is tracked as accurately as possible. This is why the collaboration with COGNIT is so important. It allows us to have a scalable and reliable system that is IoT device friendly and can be deployed on-premise, a very important requirement for different civil protection agencies. It also allows us to choose the servers with a mix of latency, energy mix, and other parameters. Here we can see a demonstration of our system. The red dot is where we'll go. Zooming in, we'll see an area of about 2 kilometers across. Each green dot is a device, and the blue circle around them is their area of activation. On the left, we see a yellow ellipse representing the wake-up area of the device. At the center of it, we see a red dot. That indicates the initial flame. And we can already see a device has detected that flame on the left, the other red dot. As we let the simulation spread, we see that more and more devices are detecting the flame, in this case indicated by the red ellipse. Every time the fire spreads, more devices will encounter the flame. And all those devices, even the ones in the yellow area, will send data to the COGNIT framework for analysis. As you can see, a short time has passed and already 40 devices are connecting to this COGNIT framework. And every minute they're sending a picture. This is why it is extremely important that we can scale reliably. Now, even more time has passed, and we're already hitting 70 devices. In a very short time, hundreds of devices can contact the framework. The Firetalker is our innovation, but the COGNIT framework provides the intelligence and power to unleash its full potential. As a proud use case partner, we're showing how this European serverless solution can help building a smarter, safer, and more resilient future for our planet. Thank you.